Muy buenas tardes. La Universidad Nacional Autónoma de México les da la más cordial bienvenida a la ceremonia de entrega de la Cátedra Maestro Ricardo Torres Gaitán 2025. Presiden este acto el doctor Miguel Armando López Leiva, coordinador de Humanidades de la UNAM. El doctor Aris Spanos, Wilson Schmidt Professor de Virginia Tech. El doctor Armando Sánchez Vargas, director del Instituto de Investigaciones Económicas. Y la maestra Lorena Rodríguez León, directora de la Facultad de Economía. Saludamos la presencia de autoridades universitarias, de la comunidad del instituto y de invitados del doctor Aris Spanos, así como de quienes a través de redes sociales hoy nos acompañan. Señoras y señores, sean todas y todos ustedes bienvenidos. Para dar inicio a este acto, tiene la palabra el doctor Armando Sánchez Vargas.
Buenas tardes, honorable presidio. Bienvenidas y bienvenidos al Instituto de Investigaciones Económicas. Es para mí un honor recibirles en esta ceremonia que no solo conlleva un significativo reconocimiento académico, sino que también simboliza la conmemoración de las destacadas contribuciones y dedicación del maestro Ricardo Torres Gaitán en nuestra comunidad educativa. La denominación de esta cátedra en su honor refleja su influencia perdurable en el ámbito académico, teniendo como objetivo fomentar y profundizar la investigación económica, especialmente en la temática relativa al desarrollo económico. Nuevamente, agradezco su presencia.
Hace uso de la palabra la maestra Lorena Rodríguez León.
¿Qué tal? Muy buenas tardes. Les damos la más cordial bienvenida a este acto tan significativo de la entrega de la Cátedra Maestro Ricardo Torres Gaitán en su versión 2025 al doctor Aris Spanos. La Cátedra Ricardo Torres Gaitán tiene como objetivo profundizar en la investigación económica y particularmente en lo relacionado con el desarrollo económico. La Facultad de Economía ha sido pionera, así como el Instituto de Investigaciones Económicas, dos partes muy importantes de nuestra universidad que han sido pioneras en los estudios de desarrollo económico, tienen ahora un reto enorme enfrente, porque estamos ante un momento en el plano económico internacional de múltiples desafíos, una incertidumbre que ha sido generada a partir de la segunda presidencia de Trump en los Estados Unidos, y definitivamente los temas de desarrollo son los que desde la Universidad Nacional Autónoma de México estamos estudiando, son los temas que estamos discutiendo porque los desafíos no son menores. Quiero agradecer la generosa invitación del doctor Armando Sánchez a participar en este evento tan significativo y por supuesto saludo con mucho con mucho gusto a quienes integran el honorable presidium y de manera particular al doctor Aris Espanos, a quien le damos la más cordial bienvenida a la Universidad Nacional y en donde reconocemos las aportaciones que ha hecho a la ciencia económica, y precisamente la entrega de esta cátedra es un reconocimiento que desde el Instituto de Investigaciones Económicas, desde la Universidad Nacional, hacemos a su labor académica y de investigación en el ámbito de la economía. Muchas gracias y muchas felicidades al doctor Espanos. Muchas gracias.
Escuchemos las palabras del doctor Miguel Armando López Leiva, coordinador de Humanidades de la UNAM.
Bueno, muchas gracias. Muy buenas tardes ya a todas y todos quienes nos acompañan el día de hoy. Doctor Armando Sánchez Vargas, director del Instituto de Investigaciones Económicas, gracias por la invitación y gracias por acompañarnos aquí en el presidio. Maestra Lorena Rodríguez León, directora de la Facultad de Economía. Muchas gracias por acompañarnos, como siempre, cuando se hace la entrega de esta cátedra. Doctor Aris Espanos, reconocido el día de hoy con la cátedra Maestro Ricardo Torres Gaitán 2025. Welcome, congratulations. Thank you for being here. Apreciada comunidad del Instituto de Investigaciones Económicas, invitados, invitadas especiales, voy a aprovechar que mis colegas hicieron uso breve de la palabra para explayarme un poquito, sobre todo relacionado con el perfil del maestro Torres Gaitán y desde luego del profesor Aris Espanos. Un saludo afectuoso de parte del rector de nuestra universidad, doctor Leonardo Lomelí Vanegas, quien no nos pudo acompañar el día de hoy. En su representación me permito expresar las siguientes palabras. En las observaciones preliminares de su libro Teoría del Comercio Internacional, el maestro Ricardo Torres Gaitán expresó lo siguiente, lo cito. Pese a todas las desviaciones y altibajos, la economía tiene en última instancia una base humana en sus fundamentos y en sus objetivos. Cierro la cita. Más adelante hace otra afirmación que me parece que es crucial. Cito. Una política sin el apoyo de una teoría opera sin rumbo fijo, y su aplicación empírica puede conducir a una política equivocada o menos eficiente. Asimismo, una teoría sin el complemento de una política concreta queda en el plano de las meras abstracciones. Cierro la cita. Dos afirmaciones relevantes que no pueden más que estar vigentes y que hacen eco de procesos actuales. De ellas podemos extraer el carácter humano del quehacer científico y el estrecho vínculo entre teoría y aplicación empírica. Ricardo Torres Gaitán es un referente para distintas generaciones de estudiosas y estudiosos de la economía en México, desde luego es sabido en este instituto, y ocupa un lugar muy especial en el espíritu universitario. Se desempeñó como director de esta entidad de 1950 a 52 y posteriormente como director de la Escuela Nacional de Economía entre el 53 y el 61. Fue reconocido como profesor emérito en 1970 y en 1988 se le otorgó el Premio Universidad Nacional en el área de docencia en Ciencias Sociales. Fue integrante de la Junta de Gobierno de nuestra máxima casa de estudios de 1962 a 1975. Las investigaciones de Ricardo Torres Gaitán abrieron sendas en temas como política monetaria, relaciones comerciales en México y América Latina, crisis y desempleo, inflación y desarrollo económico. Los análisis sobre sus aportaciones han resaltado la complementariedad entre la docencia y la escritura económica, sobre todo en dos de sus obras, la ya citada con la que inicié mi intervención, Teoría del Comercio Internacional, de 1972, y Un siglo de devaluaciones del peso mexicano, que data de 1980. Considerando el compromiso social y académico del maestro Torres Gaitán, la cátedra que lleva su nombre y cuya entrega nos reúne hoy, tiene como objetivo fomentar y profundizar la investigación económica con énfasis en el desarrollo económico, tal cual se establece en esta cátedra. Así, en ella, esta cátedra otorgada por el Instituto de Investigaciones Económicas de la UNAM y cuyos orígenes datan de 1990, reconoce desde 2012 a una persona investigadora o funcionaria adscrita a una institución distinta a la UNAM que haya realizado contribuciones al tema del desarrollo económico. Este año, como ya saben, la cátedra ha sido otorgada al doctor Aris Espanos. El profesor Spanos es doctor en econometría por la London School of Economics. Su trayectoria se desarrolla a lo largo de más de 4 décadas en discusiones en torno a la teoría econométrica. Dentro de sus áreas de especialización se encuentran la epistemología, la metafísica, la filosofía de las ciencias sociales, la filosofía de la probabilidad, la filosofía general de las ciencias. Se me trabó la lengua. Ha sido docente en el Birkbeck College de la London University, en la Faculty of Economics and Politics de Cambridge University, en la Universidad de California, en Virginia Tech, entre otros. Su filosofía docente es impulsar el pensamiento crítico y la aplicación del conocimiento. Es miembro de la Econometric Society, de Royal Economic Society, American Economic Association, American Statistical Association y del Institute for Mathematical Statistics. El doctor Spanos cuenta con más de 70 artículos arbitrados publicados en revistas científicas y libros colectivos, lo que en sí mismo habla del peso de su obra. Los journals donde se encuentran sus trabajos se agrupan en 4 tipos: los enfocados en la econometría o teoría económica, en journals de estadística, de filosofía de la ciencia y en publicaciones interesadas en temas como teoría de la información, ecología, métodos en psicología o ciencia política. Un rango de temas muy amplio. A pesar de la diversidad de estos intereses, de lo que decía ahora, un tema que se encuentra en el centro de sus preocupaciones es el vínculo entre la teoría y los modelos. Sus investigaciones sobre modelado estadístico e inferencia han estado motivadas por, lo cito, mejorar la fiabilidad de la inferencia en economía aplicada. Y cierro esta cita. De acuerdo con el profesor Spanos, las teorías son conjeturas tentativas que deben ser probadas frente a los datos. Así, la investigación del profesor, en sus propias palabras, busca, lo cito, sacar a relucir los errores y omisiones en el modelado empírico que socavan la fiabilidad de la inferencia. Cierro esa cita. Pero algo todavía más importante es que busca, lo vuelvo a citar, proponer formas para evitarlos o abordarlos. Aquí termina esa breve cita. Ha llamado la atención sobre la crisis de la replicabilidad, reproductibilidad y la falta de fiabilidad de la evidencia empírica. También ha cuestionado la aplicación de métodos sin la comprensión de sus suposiciones, limitaciones o problemas de interpretación. Su esperanza, dice, lo cito, es que las lecciones aprendidas a lo largo del camino sean útiles para delinear y abordar los problemas y cuestiones tradicionales en el modelado estadístico y la inferencia en general. Cierro esa cita. El profesor Spanos es una voz de escucha obligada en las discusiones sobre los fundamentos filosóficos de la estadística y su relación con conceptos como inferencia o lo que yo hablaba ya ahora, crisis de replicabilidad. Además de su trabajo científico en sí, podemos destacar su apertura disciplinaria y el intercambio que ha promovido con estudiantes, docentes y personas investigadoras en distintos países. En este mensaje me he permitido traer a nuestra memoria algunos planteamientos del maestro Torres Gaitán al inicio de mi intervención, así como momentos significativos de su trayectoria. Y también he trazado a muy grandes rasgos una parte del camino recorrido por el doctor Spanos que nos muestran la importancia de su obra y creo yo de por qué hoy es reconocido en esta cátedra que lleva el nombre de un exdirector de esta entidad académica. He procedido así porque pueden identificarse elementos comunes entre ambos académicos. No solo lo que los identifica en primera instancia, que puede ser visible para todas y todos, es decir, el rigor en sus investigaciones y su impacto disciplinar, sino aquellos otros que hacen converger su obra, como la conciencia sobre la base humana de los objetivos de la economía, el diálogo entre la teoría y su aplicación práctica, la esencia pedagógica de sus obras, la importancia de las responsabilidades institucionales y el reconocimiento de que de algún modo el conocimiento habrá de ser útil para planear políticas eficientes que permitan resolver problemas. Esto último, por cierto, que está en la base de nuestro quehacer universitario. A nombre del rector de la Universidad Nacional Autónoma de México, el doctor Leonardo Lomelí Vanegas, felicito ampliamente al doctor Spanos por la obtención de esta cátedra. Estoy seguro que con este reconocimiento la cátedra mantendrá su prestigio, de suyo ya muy largo, y contribuirá al desarrollo de la economía en sus muy variados enfoques teóricos. Muchas felicidades, doctor Spanos, por este reconocimiento y muchas gracias a todas y a todos.
continuación, se lleva a cabo la instalación de la cátedra Maestro Ricardo Torres Gaitán 2025. Hace entrega del acta del Comité Técnico el doctor Armando Sánchez Vargas.
Bueno, buenas tardes. Me voy a permitir leer el acta de entrega. El Comité Técnico integrado por el director del Instituto de Investigaciones Económicas, un servidor, así como José Manuel Márquez Estrada, Moritz Alberto Cruz Blanco, Rodrigo Ramírez Negrete y Alejandro Macías Ortega, acorde a las bases 4 y 5 del convenio específico, se reunió en su última sesión el día 15 de enero de 2025 con el fin de resolver a quién otorgar la cátedra Maestro Torres Gaitán. El Comité Técnico, tras llevar a cabo una minuciosa revisión de las propuestas académicas sometidas para la designación, ha resuelto emitir el siguiente dictamen. Por consenso unánime, el Comité Técnico ha resuelto conferir la cátedra Maestro Ricardo Torres Gaitán al doctor Aris Spanus del Instituto Politécnico y Universidad Estatal de Virginia, Virginia Tech, Estados Unidos, en virtud de sus méritos y destacada trayectoria en la metodología de la estadística inferencial y los modelos económicos en su vinculación con la modelación econométrica. Aris Spanus obtuvo su maestría en econometría y economía matemática y su doctorado en economía por la London School of Economics. Actualmente es profesor en Virginia Tech con la cátedra Wilson Smith Professor of Economics en Virginia, Estados Unidos. Ha impartido cátedras en las universidades de Londres, Cambridge, Chipre y California. Es miembro de la Econometric Society, del Royal Economic Society, American Economic Association, American Statistical Association y el Institute of Mathematical Statistics, además de que pertenece a los comités académicos de prestigiadas revistas. El doctor Spanus ha contribuido significativamente a la literatura académica con una prolífica producción de artículos, caracterizada por su amplia colaboración a nivel internacional. Sus investigaciones han arrojado contribuciones destacadas en múltiples áreas que incluyen, pero no se limitan al análisis de la metodología econométrica y a su vinculación con modelos económicos y de desarrollo económico, así como a la filosofía de la ciencia, lo que le ha permitido hacer relevantes avances en establecer puentes entre la teoría económica y los hallazgos de la modelación empírica. Dentro del corpus de su extensa obra más reciente sobresalen de manera prominente y a modo de mencionar únicamente algunas de sus obras más destacadas, los libros Statistical Foundations of Econometric Modeling, Probability Theory and Statistical Inference, así como los artículos Severe Testing as a Basic Concept, Error and Inference, Recent Exchanges on Experimental Reasoning, Reliability and the Objectivity of Rationals of Science, entre otros, que han sido de gran relevancia para la investigación económica y en particular para los modelos económicos y de desarrollo económico. Para dar constancia, se levanta la presente acta en el Instituto de Investigaciones Económicas a la 1:00 p.m. del día de hoy. Pues felicidades, doctor Spanus. Procedo a entregar la cátedra. Nos ponemos de pie, por favor. Este sería el acta, doctor Spanus. Congratulations.
Hace entrega de diploma la maestra Lorena Rodríguez León. Y entrega de medalla el doctor Miguel Armando López Leiva. Escuchemos a continuación las palabras y conferencia magistral del doctor Aris Spanus.
Thank you so much for the honor. I will cherish it for the rest of my life. I'm delighted to see the new generation here. They represent the future. Thank you for coming. My topic today is something that I worked all my professional life. It's about the trustworthiness of evidence in econometrics. I was very critical, even as a student, because I realized in order to have trustworthy evidence, you really need to worry about the probabilistic assumptions you are imposing on the data. And unfortunately, I was taught the usual way. You write an equation, it comes from your theory, you attach a white noise error at the, and then you kept it without worrying about the validity of the implicit assumptions you are imposing. So at age 20-something, I wrote a textbook to tell people what they are assuming about the data. The data is the only, let's say, foundation for building evidence. It's not the theory. We want the data to challenge the theory, and we usually do not do that. So here, I'm going to explain why we took the wrong turn in econometrics since the 1920s. We never realized the presence of the data and the implicit assumptions we are imposing. And as you can see, I will contrast two different perspectives on modeling and inference. One, where you write down an equation, stick an error at the end, and hope for the best, where the data simply are helping you to quantify your model. And the other, which is those assumptions about the error term imply assumptions about the observables. And there is an implicit statistical model we forget. I am going to illustrate what goes wrong if we are not very careful using an area of econometrics which had the only revolution in econometrics we call the unit roots. And I'm going to show you that the whole edifice, millions of papers published, is based on shaky foundations. And the reason is we forgot the data. We forgot to test our assumptions when we draw inferences. And I'm going to try and make a case, how can we go back and improve the situation where we actually learn from data about economic phenomena instead of just telling the data what they're supposed to tell us. So I will make suggestions how we can do that. So here we are. In any field of inquiry, from physics to philosophy to whatever, people use data. They use three basic ingredients. The first is substantive subject matter information, your theories. And those theories give you ideas about explanations. And we use those ideas to frame APP models, a priori postulated models, by attaching to those equations error terms, usually white noise. That's the first ingredient. The second, we have to choose appropriate data that could actually help us quantify and test our theories, not just fit them to the data, but really ask the data, are these theories in tandem with what the data say? Because if they are not, the estimated model means nothing in terms of learning from data, because it's basically untrustworthy evidence. And of course, the most important ingredient is you cannot do inferences, statistical inferences with data, without probabilistic assumptions. This is something very important, and machine learning and data science are going to learn about that down the road. For the time being, they curve fit, like the economists. But their models come from mathematics. They use mathematical approximation theory. But you cannot do inference by curve fitting. You really need probabilistic assumptions. And those assumptions have to do with your data. And of course, we choose these probabilistic assumptions to bring out the features of the data that we can actually exploit in terms of the probabilistic assumptions, if the assumptions are actually valid. If they are not, we are just messing around with silly numbers and telling stories. In econometrics, we've been doing that for 100 years or more. We keep telling stories. We keep bringing out new theories, and we pretend that those theories come from the data. They don't. Tomorrow, I will take a very particular case, the famous Phillips curve, and show you over the years how many papers were written with real data and what we thought we were learning along the way. I replicate all the big data, big papers, and find that none of them even comes close to having valid data imposed on the data. I use their own data, not mine. I don't want to be accused of cooking the numbers. I want them to see themselves. What they did had nothing to do with the stories they tell afterwards. Expectations here, Phillips curve is vertical. I mean, these are all little stories based on, not on the data. And of course, the primary objective is to learn from data, and we don't. So where do we go? And of course, as I say there, I have been doing it since I was a student. Take a paper, find the data they used, estimate their models, and I basically bring out the implicit assumptions they impose on the data and test them. When I began teaching, I had 50 students, graduate students. Each one was assigned a very famous paper. Their final project was to replicate the data, find out whether the assumptions they impose are valid. And I can assure you, 50 students for 7 years, not a single paper fell through. And I had later on did a lot myself. The first paper I published had a title, Revisiting the Consumption Function, Stylized Facts or Fiction. I was that bold. It took 10 years to publish it, but I published it. And I showed them there, it's fiction. So I will try to minimize the symbols, but econometrics is applied mathematics. Let's not pretend it's economic history or we can do it without the mathematics. We can't, and it's part of the problem. We pretend we teach statistics, and we don't. We just teach, let's say, how to cook things up or throw things into a computer package, and then out come the results. It doesn't work that way. We have to know what we're imposing, what assumptions we're imposing on the data. So instead of writing an equation and sticking an error at the end and hoping for the best, let's bring out what the assumptions are. So I choose the quintessential model in econometrics, which is linear regression. A linear equation between y and x, two coefficients, and an error term, which is basically white noise, normal white noise. Sometimes we leave the normality out, but then we do tests and estimators imposing normality, and that's part of the problem. So, what goes wrong? Well, we just do curve fitting. Here, if this works, I have notation for an APP model, an equation stick an error at the end, and then when I get the statistical model, I change it, the phi to a theta, just to keep them separate so we don't get confused. And of course, what we do is just quantify or estimate the parameters. We choose as many assumptions about errors as we need in order to do inference, but we never test them. But those are not the assumptions that actually matter. The assumptions that matter are the ones, those assumptions together with the equation imply about the observable process underlying the data we use. Those are the ones that provide the foundation of inference. And of course, we use these error term assumptions to guide us, derive sampling distributions, confidence intervals, test hypotheses, and aware that those are not really the assumptions that matter for the reliability of your inferences. So there is a missing step. Let's dig out those assumptions. And of course, every time you do econometrics, you have to learn these asymptotics. As n goes to infinity, this estimator is good. How much value is that? 0. That's just an excuse. As n goes to infinity, as I tell my students, and Armando was one of them, is the afterlife. It has nothing to do with this life and this data. It tells us nothing. So pretending we can do inference as n goes to infinity is too much to expect. And I'm going to quote somebody else, not myself, later on. So the key issue, however, is not every model you just wrote down, put an error at the end, is well-defined statistically. There's no reason to be statistically well-defined, so you can use data and quantify it and do the inference. And I'm going to show you today a very famous model, the autoregressive model. Actually, doesn't exist because we are not very careful how to do it. And of course, what matters for inference, I'm going to repeat myself many times today, is not the error term assumptions, are the assumptions we actually indirectly impose on the observable processes that, let's say, relate to the particular data. So all the assumptions should need to be on X, Y, and Z, not unobservable error terms that nobody can see. And of course, they can be easily abused. So how do we dig out these implicit assumptions? It's non-trivial. Sometimes it looks trivial, but there is more to it. So we start with the error assumptions and then transfer them onto the Z. Z here is for both Y and X, the two observables, and the two variables we have data for. And in this particular case of the simple normal linear regression, the assumptions that we are imposing on these 5, even if we do the transfer up there, we miss out on the most important of all the assumptions. Why? Because we take the equation as at face value. So we say the coefficients are constant. Why? That's the most important assumption. Because if the coefficients are not constant, what you're estimating is 1 out of n different values. They don't exist, in other words. So this I published, of course, back in the 80s. And We get this model by digging out what assumptions we're imposing on X and Y, and this is the distribution they depend on. And as you can see, these coefficients here actually have a meaning. They are not something I wrote down. The intercept here is a linear combination of the means. The beta is the covariance between X and Y over the variance of X. And so is the sigma square. So when we do this unveiling of the implicit statistical model, we learn a ton of things. And every one of these comes out of the assumptions we impose, normal IID for this process. So this is what we need. Test the 5 assumptions. If they're valid, go ahead and do your inference. If any of them are invalid, re-specify. Make different assumptions about Z and get a different model. We can cook models instead of getting stuck with 2 or 3 models and hoping that our data will fit well. And of course, here I tell the big story, how this perspective, the statistical perspective, is so different. I'm not going to bore you with the details, but if people are interested, I'll be more than happy to send you the details here and just go straight down here. Why are the assumptions we are imposing on the observable stochastic process the important ones? Because all inferences depend on the distribution of the sample. It's not the distribution of the errors. It's the distribution of the Z for theta that comes out of these probabilistic assumptions. And of course, the likelihood function is just that where we replace the Z with the particular data. Anybody who has done statistics, you know, if you have the distribution of the sample, you have everything you need to do inference. The likelihood function is just another form of the joint distribution. And you need one estimator. The maximum likelihood is always better than anything else. And if you define all the assumptions, there is always a maximum likelihood estimator. We don't need OLS, GLS, IV. These are gimmicks that come out of, let's curve fit, assuming that the error terms that we have never seen are correlated with observables. How is that an assumption? That's wishful thinking. So how do we put all these pieces together and realize why are these people doing what they're doing when in fact they should be talking about statistical models? Because there is a role for the APP perspective. There is a role, but not for modeling and inference. So here, the role is, if we have a substantive model, which we view as a system, and we want to know how it behaves under different shocks, that the error term here is shocking the system to evaluate its stability as a known system and fine-tune its performance for forecasting and policy and control purposes, that's what we should do. But when we are building the model, it's not one of those things. So let's build the model first. And the other perspective, of course, is the statistical. And that's what we should be using to direct the modeling and the inference. The modeling is not just curve fitting. You estimate the model, test the assumptions. If they are valid, you proceed. If they're invalid, you re-specify. And testing the assumptions is non-trivial. It's easy to do, but you have to do it systematically. And of course, this is what we need. If we use this APP perspective, a priori postulated perspective, to guide modeling and inference, we are asking for trouble. And that's exactly what happens in econometrics. Somehow, the observables and the data don't really play any role in what we are doing. And of course, the probabilistic assumptions matter for modeling and inference simply because they define the distribution of the sample and then everything else that goes with it. So here, I repeat myself to remind you, Of course, the statistical model is that joint distribution, but it has a set of parameters, and those parameters do not have to coincide with the APP model parameters. A lot of times they don't, but these ones need to be probabilistically well-defined, and they should be supported by statistically aggregate assumptions, valid assumptions for your data. Now, the most important formula in inferential statistics is this crazy-looking multiple integrals. I don't write it there to intimidate anybody. Forget the rest. This is how we derive sampling distributions of estimators, test statistics, predictors, simulators, the whole shebang. We start from the joint distribution of the sample, and then we integrate over events relating to this statistic, any one of those estimators, think of estimators. But the way we do it is we assume this distribution of the sample is well-defined probabilistically. In other words, it satisfies Kolmogorov's existence theorem. It exists probabilistically. And two, our assumptions defining this thing here are valid for this data. Those are assumptions implicitly posed when we derive the sampling distribution is normal or students T or chi-square or F-distributed. This is what we're doing. But we make these two assumptions. So what can go wrong? Well, this always goes wrong in econometrics. The assumptions are never tested. I do it for them. I discover they are actually false. But this is also important. Is there such a distribution? And I will show you today that 7 million of published papers assume the existence of something like that for the unit root modeling that doesn't exist. It doesn't satisfy Kolmogorov's existence here. We need both of these. So what happens and what goes wrong? Now, if your assumptions are invalid, two things happen immediately. This is wrong. So if you go back and you derive using the wrong distribution of the sample, everything will go astray. Let's go forward. The likelihood function is wrong. So what do you expect is going to, you are talking about optimal estimation procedures and a uniformly most powerful test. Where? How would you get that if your distribution of the sample is actually false for your data? It doesn't work. You get all kinds of gibberish. And of course, you get non-optimal estimators. You think you have a maximum likelihood estimator with all these wonderful properties, but you really don't. And of course, what goes really wrong is how do we actually relate the reliability of inference to all of this? Well, think of doing testing. Remember Neyman Pearson testing? You assume the type 1 error, 5%, 2%, 1%, depending on the number of observations, and you derive a uniformly most powerful test. Now, what goes wrong in testing? Well, your error probabilities are not the ones you think they are. In other words, the ones you think are the ones you derive, assuming everything is hunky-dory. Your distribution of the sample is beautiful, the assumptions are valid. If they are not, you're shooting yourself in the foot. That's what happens. And of course, you are doing a 5% significance level test, but your actual type 1 error is 97, 100%. And I have many, many simulations that show that. So those who have access to my 2019, I have tables where I show you what happens. Your actual error probabilities are not the ones you think. They're very different. So your inferences are wrong in that sense. Why? Because, let's say, a misspecified distribution of the sample will throw huge discrepancies between the actual and the nominal error probabilities. And of course, the end result is untrustworthy evidence. That's why we swim in untrustworthy evidence. Regrettably, in econometrics, we forget all of this. I don't know who teaches the inference part and all of this, but they seem to be very happy using the error to play around with games and testing very little or nothing. And of course, it's important to keep in mind that things can go wrong immediately if there is no such joint distribution. And that's the example of this revolution I mentioned before, because Kolmogorov's existence theorem doesn't really hold. So here we are. It looks like regression. This is your regressive model of order one. The whole of that literature revolves around these three models. No constant, a constant, and a trend. And of course, there is a common error term, a generic error term, which are never generic with statistical models. And we decide that alpha 1 takes values between -1 and +1, including the boundaries. Is there a distribution to support that? And my answer is no. There is no joint distribution that will give you alpha 1 equals 1, which is the unit root hypothesis. These are not well defined in terms of Kolmogorov, and of course, the assumptions are never tested because they never really written in terms of those assumptions. So in this particular case, of course, there is a lot of technical stuff, but I'm not going to bore you. Just tell you that if you do this transferring here, it's not going to work because you have dynamics. And people can see the actual paper, but you can prove, let's say mathematically, that the assumptions there are incomplete. And of course, the general likelihood function or distribution of the sample here, this is wrong because we play around with these initial conditions when we shouldn't. And of course, remember, a conditional distribution is defined in terms of a joint distribution. Look at this. This is the joint distribution, and this is the joint distribution integrating the YT, in order to get the YT minus 1 marginal distribution. We never asked, is there such a thing to define this, which looks like that? We never asked that question. When I did 45 years ago, I realized Kolmogorov doesn't hold. I tried to publish it because people went berserk. So are you crazy? These people here have IQ unbounded above, and you're telling us they made such an elementary mistake? Yes. It's not about IQ. It's systematic thinking. This is the definition of a conditional distribution here. But that requires you to have the joint distribution. There's no other way to do it. Conditional distributions do not grow on trees and you go there and pick them. You construct them, but you need a joint distribution. And of course, it turns out for alpha equals 1, this breaks down. And of course, remember that formula, the crazy integrals? If the joint distribution of the sample is mistakenly thought to be this one, what do you think is going to happen? Your inferences are going to be all over the place. So we discovered in the late 40s several conundrums that go with the unit root literature. What conundrums? Well, the sampling distributions of alpha 1 and alpha 0 and sigma square are not standard. They're not normal, chi-square, students T, and all the rest. Oh, they are actually Brownian motions. And of course, people just played around with that and extended it left, right, and center as if it was the magic. Then they realized when they start testing for alpha 1 equals 1, the unit root, the power of the test based on this kind of sampling distributions was extremely low. For 0.9 and above, to 0.9 to 1, the power is less than 30%. Don't do tests with 30% power. You're going to accept the null every time. Then they realize there are other problems, like size distortions. The type 1 error is never 0.05 if you do 5%. It's very different. So they went to work, tried to remedy the situation, and of course, there were another 5 or 6 problems. This doesn't involve invalid assumptions about data. This is the construction of the implicit statistical model. And of course, the reason is it's a bad joint distribution because it doesn't really satisfy common goals. Let's say existence here. There is no such process. This is the statistical AR1 model. The alpha 1 cannot be 1. Why? Because if it's 1, the variance of yt minus 1 and the covariance between the two is equal. And then, of course, you get a singular distribution. There's no model. It's just the probability of yt equals yt minus 1 is 1. And look at what happens to this guy. If alpha 1 equals 1, this falls apart. Now, deriving the implicit statistical model was tricky, but this here is an if and only if. These 5 assumptions are equivalent to assuming that the process y is normal Markov stationary. And the surprise was, if you actually try to do that, all of these things will happen to you. It doesn't exist. That's why you get low power and you get all the rest of it that we spent the last 40 years remedying without actually doing very much. And of course, there is a very different statistical model for the unit root, and the 2 models are not even nested. In other words, one is not a special case of the other, because it's based on a very different distribution. Yes, when I go to the conditional, it looks as though the only difference is that one there. It isn't. This is really very different distribution. So how do they get away with all of that? And of course, the parameters are extremely different. Let me just go back for a second. Look at what the constant here is and what the constant here is. It's just M1, which is never in the other model. This assumes a trend for the unit root. And of course, I do it for all the 3. Here are the statistical models for the AR1 process. Here are the unit root processes. They have very different parameterizations, very different assumptions, and one is not the special case of the other. There are 2 distinct families of models with different probabilistic assumptions, distinct parameterizations. Look at the constant and the trend and all of that coefficients, and you will see they are not even related. And here I tell you what happens because the likelihood function is going to be completely off and all the usual things. How do they actually justify it? Well, they basically tell us that there is a quantum leap between alpha, which is very close to 1, but not quite. The minute you go to 1 tiny little thing, 3 things happen. It transforms a stationary process into a non-stationary one. It fuses the 2 models into the APP-AR1 and transmutes the standard into non-standard sampling distributions. No, they don't. It's just a mistake we made, and we spent 40 years trying to correct it. And of course, there's no correction. You have to go back and do a better job. Conclusion, the unit revolution has been unwittingly caught in a vicious circle. The joint distribution of the APP or regressive models implicitly invokes a well-defined process, which is not true when alpha equals 1. And of course, the end result is the conundrums. Not to say anything about the wrong assumptions, which of course they are because they never tested it. So What do they tell us? Oh, these are the error assumptions. The limit of the, let's say, the average of the error terms ad infinity is positive. How am I supposed to test that? Here, this is bounded. How on earth is that? And then, of course, three, we have strong mixing. This is what happens in the afterlife. I want to know what happens in this life. What are the assumptions? The assumptions are the 5 assumptions I gave you, but they use that as an excuse. And of course, those are non-testable. They don't define it with defined distribution. And of course, they invoke the asymptotics. You don't need the asymptotics. I do simulations for my models, and they are perfectly fine. They are normal students, T, chi-square, and F, and the power is amazing. They don't have any of the other problems as well. So we got it wrong from the beginning, and then, of course, we keep insisting. So Lecam is my hero, because for years and years I was saying, asymptotics is the afterlife, please. Stop it. He says, this is a book on asymptotics, by the way. He says, limit theorems as n tends to infinity are logically devoid of content about what happens at any particular end. It cannot be clearer than that. Logically devoid. There's nothing there to use. And of course, what you need to learn from data are not weak assumptions. You need strong assumptions to get precise results and learn from data. But you need to test them. So this, I have weak assumptions so I can do whatever I want. It's just a silly dream that really doesn't exist. So weak and incomplete, non-testable probabilistic assumptions about errors, it's creating mountains of untrustworthy evidence. And let me conclude. The title, of course, is Why Has Traditional Econometric Model Failed to Engender Genuine Learning from Data? The answer is the untrustworthiness of empirical evidence is due to the traditional perspective. I define econometrics in 86, and I define it as is concerned with quantifying, with the systematic study of economic phenomena using observed data. And systematic was really the operative word there. The definition at the time was econometrics is concerned with quantifying economic relationship using data. No. We do statistics. We don't do self-feeding. So it failed, econometrics, it failed to give us real learning from data because we play games with the error process, unobservable error process, instead of assumptions about observables. And of course, these assumptions are never tested, and we have the consequences. Econometrics adopts the strategy of finding the weakest set of probabilistic assumptions, which would give rise to asymptotic inferential components, the so-called, let's say, consistent asymptotically normal. We reject normality as an assumption, and then we bring it back from the afterlife to do inference. And of course, lastly, non-testable, and so on and so forth. I'm not going to bore you. The proposed strategy for me is to immediately transfer your probabilistic assumptions from the error to the observables, unveil, in other words, the implicit statistical model, and basically test your assumptions, establish the statistical adequacy, and then, of course, everything else will follow from that. Now, I'm a big critic, and I'm not particularly popular among econometricians, but that's fine. I don't want to, let's say, win popularity contests, but when I get a chance to give a seminar and they are in the audience, suddenly there is a lot of fighting. I don't mind that either. I know I'm right. I replicate the thousands of papers. So, am I the only guy? No. Thankfully, I'm not the only econometrician statistician who says any of that. A lot of other people do. Basically, the unreliability of inference and the untrustworthiness of the empirical evidence stem primarily from the uninformed and recipe-like implementation of empirical modeling and inference. Here are two distinguished statisticians at the Berkeley School of Statistics, founded by no less than Jerzy Neyman himself, publishing a paper in 2018, saying practitioners go through the motions of fitting models, computing p-values, or confidence intervals, or simulating posterior distributions. They invoke statistical terms and procedures as incantations, magical spells. I had difficulty with that word. With scant understanding, with no real understanding of the assumptions, what I'm screaming my head off, or the relevance of the calculations, or even the meaning of the terminology. But that's the punchline here, reinforced and abetted by statistical education, statistical software, and editorial policies. That's where things go wrong. A lot of my papers take years or decades because they say it doesn't sound familiar here. It's not the kind of paper we want to publish. It's the excuse, verifying themselves. So the last part is actually the most important. This devotes statistics. It brings statistics down to a way of thinking about evidence, instead of talking about evidence and learning from data, and avoiding self-deception. In other words, we need trustworthy evidence, to a formal blessing of claims. I did all of this. I'm now entitled to give you explanations and theories supported by the data. It's not supported by the data. So, is there something to do? Yeah. Substantial overhaul of the teaching of probability statistics and econometrics. These statisticians tell you, it's just, you are reciting terms. You throw your data into a computer package, out they come and you tell stories. There's nothing in between. The stories, of course, have nothing to do with the data. And, of course, we need to change the statistical software. We need misspecification testing. Let's say, brought it into the, so they do it automatically and say, these are your problems. Then they cannot use this excuse. And most of all, tell journal editors. If somebody submits an applied paper, ask them, show me that your assumptions are actually valid, the assumptions about the observables. Otherwise, get your paper back. It will force everybody to really be a lot more careful. And of course, I'm not expecting any time soon that will happen. Let me finish with the good news. Here at UNAM, since the late 1980s, econometrics was taught more often than not the right way. Julio Lopez, fortunately, he died a few years back, called me here in the late 80s, and he and I were teaching a course to the professors for 4 weeks. They got it. They know the value of testing assumptions. And now, of course, he passed the baton to Armando Hutchins, because he actually, I taught him econometrics at Virginia Tech. Thank you for listening.
Es así como damos por terminado este acto. A todas y todos ustedes, muchas gracias. Muy buenas tardes.